Now that we've gotten the centroid calculations of simple shapes done, we're going to take a little time and make our life a little bit more interesting. So we know what the basic formula is for basic shapes, and if you don't know, then you'll have to go back to the previous video, or you're going to need to look them up. Those shapes that we're going to end up being using are a right triangle, a half circle or a semicircle, and a rectangle. Most of the things that you'll see in life are combinations of these or some other way to put them together. So this isn't an inclusive list of everything, but this will get us by for what we need to do right now. I'm going to go ahead and draw a shape up here, and we're going to try to find the centroid or the center of mass of this shape. Pretend that I can draw straight lines. It's only a pretend. There we go. Okay, so this is a trapezoid, and I'm going to say that the trapezoid has a height of 4 units, and I'm going to say that it has a length on top of 6 units and a length on the bottom of 10 units. And let's say that we're going to need, yeah, we need this. So let's just go ahead and put this down here. If this is 6 and this is 10, then that means that this base of this little part on this side is going to be 4. Now, we can make a guess on where the centroid is without doing calculations, but it's a lot more important for us to be able to get the centroid of this object by calculating it out. Like, we know that the x direction is going to be somewhere on the heavy side, so where there's more stuff. So we know that from the length of 10, it's going to be more like on the left side. And we also know that for the vertical side, it's going to be more towards the bottom. So the centroid is going to be kind of towards the left and the bottom in this case. And what we want to try to find out is we want to try to find out what the centroid is. And here's what we need to do. So this is actually kind of broken down into two shapes. So the first thing that we're going to need is we're going to need to actually identify what these are. So I'm going to call this S or R for rectangle, and I'm going to call this T for triangle. We're going to need to get the areas of both of those. The rectangle has an area of 6 times 4, so the area of the rectangle is going to be 24 units squared, which we'll just write u squared for the units. And the triangle on the other side is 4 by 4, so that's going to be the area of the triangle is going to be 1/2 the base times the height. So that's 1/2 of 4 times 4, which is half of 16, which is going to be 8 units squared. We're going to need those areas later on whenever we get to it. So the first step that we need to do in terms of like trying to calculate where the centroid is we need x bar and y bar. So x bar and y bar are going to need a reference. So I like to try to use the bottom left if I can get away with it. And in this case, since there's a nice corner in the bottom left, that's the one that I'm going to do. So I'm going to make a reference point right here on the bottom left. I'm going to write O for origin. And I need to find the x bar and the y bar of each one of these shapes. So there's a rectangle and there's a triangle. I need to find the x bar of the rectangle and I need to find the x bar of the triangle. And this is where things start to get a little bit interesting, and we have to just make sure that we don't accidentally do things that we don't want to do. So we can miscalculate here for really simple reasons, not for anything like super complicated, but for like really simple reasons. So it's easy to get things backwards or just flat out omit them. So we're going to have to be a little bit careful about that. So I'm going to just put a little space right here. So I'm going to draw a line down. On the left side, we'll put everything that's for the rectangle, and on the right side, we'll put down everything that's on the triangle side. So let's find the x bar of the rectangle. So for the rectangle, x bar is going to be, let's see here, switch this back to blue. It's going to be halfway across. So we're going to be looking about where this point is here. So it's 6 units across, so the x bar is going to be 3 units in the right direction, so that's a positive number. So it's going to be 3 units to the right. The y bar is, the height is 4, so for the y bar, we're going to go up halfway. So I've got the y bar, and that's going to be equal to 2 units. Oops, that was black, not blue. That's okay. So that is our x bar and our y bar, and then we also have our area as well too, and that's going to be important to us as we continue to move along. On the other side, the triangle has a height of 4. So for the, oh, let's do x bar first, sorry. So we'll do y bar, and then we'll do x bar. Okay, so the x bar has, the base of the triangle is 4, and I know that in order to find the place across the x bar location, then that's going to be the base divided by 3 according to our simple formulas that we have for our simple shapes. So I know that it's b divided by 3, so that's 4/3, but I can't just write, even though that this is where I'm referencing it from, this is not my reference point that we made for the big shape, the complicated shape. So what we're going to have to do is we're going to have to add 6 to this. So 4/3 is 1.33. So we're going to add 6 to that. So that's going to have an x bar of 7.33 units. Okay, and the reason why it is 7.33 units is because I'm starting at the origin, and since I'm starting at the origin, I'm trying to use the distance. Let's see if we can actually get a highlighter going here. I'm going for the distance from the origin all the way over like this. Okay, all the way over to the side. So that's a total distance of 7.33 units. And then for the y bar, since we are referencing it from the x-axis, I don't have to do that. My y bar is only going to be 1.33 units up because the height is 4. So that's 4 divided by 3, or 1.33 units going up. Okay. The next thing that I need to do is I'm going to have to take my x bar and I'm going to have to multiply it by my area. So I'm going to go ahead and do that. So I'm going to go ahead and get both of these. So the area for the rectangle is 24. So I'm going to take, and it doesn't, for the x bar and the y bar, I'm going to do that for both. So I'm going to multiply this. X bar times the area of the rectangle is going to be 3 times 24. I'm going to multiply that out, and that comes out to be 72. Okay. The next one, technically that would be units cubed, but we're really kind of only interested in the number right now for the moment. The areas are going to end up canceling, and I'll show you that in here in just a second. The y bar, so let's go ahead and do that. Y bar times the area of the rectangle is going to be 2 times 24. So I'm going to multiply that out, 2 times 24, and that comes out to be 48 units. On the other side, we're going to do the exact same thing, except our area of our triangle is much, much smaller since it's only 4 by 4. And since it's a triangle, you lose a lot of area in that process. So I'm going to multiply this out. So we're going to do x bar times the area of the triangle this time. So I'm going to do A with a little t underneath it for the area of the triangle. So it's going to be 8 times 7.33. And that comes out to be 58 point. Since we're keeping this, let's go ahead and just keep this to the tens place. I'm going to say 58.7. 58.7 units cubed. And then the y bar is going to be times the area of the triangle. It's going to be 1.33 times 8. It's going to be 1.33 times 8, and that's 10.64. So we're going to write 10, keep it with one decimal, let's do 10.6 units. Okay, so now we're going to need a formula for the area of, I'm sorry, we're going to need a formula for the centroid location. So to get the centroid location, what we have to do is we're going to have to sum up on the top the areas times the x bar. Let's go ahead and just make this is the sum of the product. So I'm going to have to add up the areas of the products up here and then multiply it by x bar, and then I'm going to divide it by the sum of the areas themselves. Okay, and then that's for the x one. And then for the y bar, we're going to do the same thing. We're going to do the sum of the products of the area times y bar, and then we're going to divide it by the sum of the areas. Messed up on my notation there. If you've never seen the little squiggly guy that looks like a giant E, that's the Greek letter sigma, and that stands for sum. And a lot of people right now are looking at this and you're saying, well, wait a minute, if that is the sum of the area times x bar divided by the sum of the areas, can't I just cancel out the sum of the areas? And the answer is no, please don't do that. There's a reason why it's written like this, and let me give you an example of why this is a bad idea. Let's say that you have some of your products up there at the top, and it ends up being like, I don't know, 2 times 3 plus 4 times 6. And then at the bottom, since you're summing the areas, let's just say that the areas were both 2 and 4. That's going to be 2 plus 4. You can't take this 2 and this 4 and factor it out and then cancel these. That's a very, very bad, that would be like, you can't be like, bye-bye, bye-bye. That would be very, very bad. Please don't do that. Math says no in that case. So even though it looks like from the formula that these things can be canceled out, they really cannot be canceled out because you're dealing with a sum. You're dealing with a large amount of addition of the products on there. So whenever we work this out, we're going to get a centroid value of the x position and a centroid value of the y position. And it's just going to make an ordered pair. So let's just scroll down a little bit and let's work these out. And hopefully I've got everything. Yeah, I've got the products, and I might have to go back up for the areas, but we'll see. At the first one, it's the sum of the areas times the x bars, and we have those. So for the x bar times AR, there's 72, and the sum of the x bar times AT, that's 58. So I've got to add 72 and 58.7. So for this first one, it's 72 plus 58.7. And then on the bottom, it's the sum of the areas of both of the x, or sorry, the sum of the areas of both of the units. So it's 24 plus 8. So 24 plus 8 is going to be, let's see here, make sure, absolutely sure that I don't mess this up, 32. So I'm going to put 32 down here at the bottom. So once we calculate that out and do 72 plus 58.7, divide that by 32, that comes out to 4.08. So this is going to be our first part of our ordered pair. So I'm going to go ahead and write parentheses here, and I'm going to write 4.1. I'm going to just round it up to the nearest tens place. It said 4.08, but I just made it 4.1. For the other side, we have two area times, we have two products up here. We have the AR times Y, and we have AT times Y. This is the area of the rectangle times Y and the area of the triangle times Y. So what we're going to do is we're going to add, that's 48, okay, 48 plus 10.6, and then we're going to divide it by the sum of the areas again. The sum of the areas again is just 32. That number didn't change. So we're going to add those two together, 48 plus 10.6, and then we're going to divide by 32, and that comes out to 1.8. So I'm going to write 1.8 down here for the other part of my ordered pair, so that becomes 1.8 for the y direction. And let's actually see if this makes sense. I think it does, because this is really close to the heavy end instead of the light end, and this is close to the heavy end instead of the light end. So I'm going to scroll back up here, and I'm going to see if that works out. So 4.1, 1.8 is going to be about, 4.1 would be less than halfway across, so it'd be about right here. And then 1.8 is going to be a little bit below the halfway point, so that actually works out in that case too. So it looks like it actually works out in both cases that that's going to be the centroid for that problem. So that is how you would work a example of a centroid in a complicated situation. And the formula to be able to do that is you're going to have to do the sum of the a times x and the sum of the a times y. And I believe that's it. You guys have a great time, and I will talk at you later.